All right, now we're asked to multiply, and I just want to emphasize that multiplication is not a problem. We have a way to show the result of multiplication. We multiply the coefficients, numbers in front of the variables. We add the exponents of the variables. So we have a way to show that. But if instead of this expression, if you had a different one that said 2x to the 6 negative 3x, but now there's no parentheses, so it's adding or subtracting. And let's say this was plus 4x to the third. In this case, you wouldn't be able to do anything. Okay? But up here, because you're being told to multiply, that's not a problem. All right, so 2 times negative 3 is negative 6. Negative 6 times 4 is negative 24. All right. X to the 6. This x here has an exponent of 1. So all you have to do is add 6 and 1 is 7, plus 3 is 10. X to the 10. So that's the result of that calculation. Taking a look at number 55. All right, this one's a little bit more confusing to look at. Basically, you have a number, bunch of variables, number, whatever you want to call it, a term, in front of parentheses. So this means to multiply this times each term inside the parentheses. All right, so this whole thing is going to multiply the first term, the second term, as well as the third term. Okay? And let's get some scratch paper here. So 6 times 5 is 30. All right, move this up some. 6 times 5 is 30. X squared times x to the third, that's x to the fifth. Just add exponents. Y to the fifth doesn't have anything else to multiply, so it just comes along for the ride. Okay? Then our very next term, positive times negative will be negative. 6 times 6, 36. X squared times x squared means you add exponents, so you'll have x to the fourth. Y to the fifth times y squared means you add exponents. Y to the seventh. And then moving over here, 6 times a positive 5 is positive 30. X squared doesn't have anything to combine with, so it just comes along for the ride. Okay? And then y to the fifth times y third. When you multiply your y's, you add your exponents. So that's y to the eighth. All right? You distributed this term to each term inside the parentheses, and this is the result. So that's 55. We're also going to tackle number 59. Notice on these, the ones 52 to 56, you just have, well, it's not even as clear here, but 54, 55, and 56. There's basically one term in front of parentheses, so you would send it in to each term inside the parentheses. But when you get to 57, you have two terms. This set of parentheses in front of this set of parentheses. So I want to talk a little bit about that meaning and just build it up. Because what's really important is that you get good at reading the shorthand of mathematics. So for ones like 57, 59, all the way up to 61, it's really the same idea over and over. It just looks a little more complicated each time. So I'm going to try to emphasize that. Let me zoom out real quick. All right, and notice each of these expressions has 3x to the fourth, 5x squared plus 7. Okay, so this set of parentheses is identical, and each of these is going to get multiplied by a 2y. This is going to get, all this is going to get multiplied by a 2y, but also this. And then all of this is going to get multiplied by a 2y, but this and this. Okay, so it's just reading the shorthand. If you have something next to parentheses, it means to multiply. So this 2y is going to have to hit each term inside. That's going to give us 6x to the fourth y. Over here we'll have plus 10 x squared y. And then over here we'll have plus 14, and this y just comes along for the ride. Okay? So this would be the solution to distributing 2y to each term. All right? But here you have to distribute not only the 2y, but you also have to distribute the x. This is the meaning of math, or the math shorthand. If you have parentheses next to parentheses, each term in here has to multiply each term in here. Okay? So I usually start off with my first term to do this in an orderly manner. Okay? So this x is going to have to multiply 3x to the fourth, 5x squared, as well as 7. And then I'm going to come back and make sure that this 2y multiplies each term. Alright, so the first one, this would give us 3x. When you multiply variables, you add exponents, so x to the fifth, plus 5x to the third. Remember, there's a 1 on this. And then plus 7x. Alright, so we've taken care of distributing the x to each term. And now we need to distribute this 2y to each term. Okay? So 2y times 3x to the fourth is going to be, let me slide this over. None of these are going to combine. If I was able to stack them up and combine like terms, I would, but I'm not going to have any like terms. So this would be plus 6x to the fourth y. Okay? And then so 2y times 3x to the fourth yields that. 2y times a positive 5x squared will give us plus 10x squared y. And 2y times 7 will give us plus 14y. Okay, and again, I'm just trying to emphasize each term here has to multiply each term here. One more for the grand finale. We'll start out with our very first term. The 6 has to hit each term. Slide that down. That's not working too well. This one's going to get rather large, I anticipate. So 6 times 3x to the fourth is 18x to the fourth. 6 times 5x squared is 30x squared. 6 times 7 is plus 42. We've taken care of our first term. Now the next one, we'll send this x into each term. So x times 3x to the fourth is 3x to the fifth. X times 5x squared is 5x to the third plus 5x to the third. And then finally x times the 7 is plus 7x. Alright? And then finally send our 2y in. Alright? So 2y times 3x to the fourth is going to be plus 6x to the fourth y. 2y times 5x squared is 10x squared y. So that's plus 10x squared y. And finally, 2y times 7 is plus 14y. Okay? So I'm just trying to emphasize each term here hits each term here. So back to the problems that were actually given. Number 59. Okay. And I don't think I'll really need this, but so again, I just like to do this in an orderly way. I start with the first term in this set of parentheses, and 5x squared times 6x squared, that's 30x to the fourth. I think I'll zoom in a little here. There we go. And then 5x squared times this 5 is going to be positive 5, so positive times positive is positive. 25x squared. Now we're going to multiply this negative 8 times each term. In fact, I'll move this down a little. Negative 8 times 6 squared, negative 8 times 6x squared is going to be a negative 48x squared. I'm going to put it underneath here just because it's a like term. I could have just as easily written it to the side. And then negative 8 times positive 5 would be negative 40. I can combine these two like terms. All right, so I'll have 30x to the fourth. The signs are different, so the answer is going to be negative, but I cannot do the subtraction in this form. Okay, you need to sneak off to the side, so to speak, and let's see. I'll do my calculation way up here. I have 48 and 25. The signs are different, so I'm subtracting. I'm going to keep the sign of the larger. It's going to be a negative something. Negative 23. Okay, so the result of that is negative 23. You keep your x squared, and then just minus 40. Okay, so this is the solution to number 59. Obviously, yours is probably different, but it follows the same pattern. Let's see another one. We'll do number 63 here. And 63 might look different, but they really are telling us to do the same thing. You cannot just send in that 2. All right? If you had, let's say, 7x, y, let's just say to the 5th power. I'm just making one up here. And then instead of minus y, I'll just put the letter z. Okay? And we'll make this one squared. If you had 7x y to the 5th z squared, all raised to the 2nd power, this means you have 2 sets of parentheses. But the shortcut that we learned is you can just send in that 2. Sorry, I got to multiply the exponent on the 7, which is a 1, the exponent on the x, which is a 1, the exponent on the y, and the exponent on the z. So the shortcut is you just send in this exponent and multiply by each exponent that's inside the parenthesis. But when you have terms being added or subtracted, you cannot just send that in. You will end up with the wrong result. Okay? So we're going to have to be more careful with the strict meaning here. You have an exponent touching parentheses. That means that you have 2 sets of parentheses. That's what it means. That's what it means here, but we have a shortcut. Okay? Here, there is not a shortcut until you learn the pattern. And inside parentheses, we have 7xy and minus y, or negative y, however you like to say it. The meanings really are the same. And now this looks like number 59 that you did earlier, right? Okay, so this is number 63. And let's move this up a bit. And again, just make sure that each term hits each term. This 7xy is going to have to hit the first term as well as the second, and then I'll come back and deal with that negative y. Okay, so 7 times 7 is 49. X times x is x squared. Y times y is y squared. Alright, so that's our first one. 7xy times a negative y is negative 7x y squared. Alright, we've taken care of the 7xy going to each term. And now we have to send our negative y to each term. Okay, so that's coming over to here. So negative y times this is going to be negative 7x y squared. And then negative y times negative y is plus y squared. I could have stacked these up, but I didn't. But they are like terms. Alright, so your last step here, you're going to have to combine your like terms. And notice negative 7xy squared, negative 7xy squared gives us negative 14xy squared. The x and y squared just come along for the ride. And you have to bring down your 49x squared y squared. 49x squared y squared. And you have to bring down your plus y squared. Okay, so this is the solution to that one. And let's see, we'll also do 66 and 68. Maybe we'll finish this one with 66, okay? So, and I'll try zooming in a little bit here for you. Alright, so each term has to hit each term. By the way, they said multiply using the FOIL method, and that's just a way of keeping up with the terms. That's basically what we did, say, way back here on number 59. We did the first terms, that's the F. O stands for outer, I stands for inner, and then L stands for last. If you want to say, oh, the FOIL method, that's fine, but you might be better off just saying each term has to hit each term, because the same reasoning you're using for FOIL is the reasoning you're using, for instance, here when you have 3 terms stacked up. Okay, so we'll just crank out number 66 here, and that'll finish this video. So you have negative 5x times negative 2 is positive 10x squared. I probably didn't need that positive sign. Negative 5x times positive 8, negative 40x. All right, and then you got to come back and make sure your negative 12 hits each term. So negative 12 times negative 2x is plus 24x. And then finally negative 12 times positive 8, negative 96. And you have to come back here and combine your like terms. Alright, so you've got negative 40x, positive 24x. When you combine them, you're going to get negative 16x. And then you bring down the other 2 terms. You can't forget about them. So this is 10x squared and negative 96. And the last video, so again, this would be the answer to this problem.